everybody for coming. I'm Jonathan Comstock. I'm the HeatSmart director. HeatSmart is a program of Solar Tompkins. So Solar Tompkins is the organization. HeatSmart is the activity that we're running this year. And I'm going to start with just a few comments on who Solar Tompkins is and who the people are that are putting on this program. So, first of all, Solar Tompkins and the HeatSmart program is mostly run by volunteers. And it's a very homegrown local effort. We have board members from every town and city in the Tompkins County area. And the volunteers are motivated by concerns for climate change and just other pollution and negative impacts of our current energy use. So this is going to be my only climate slate change slide, but huge impacts are happening right now. We lost a quarter of the Great Barrier Reef of Australia last year, in 1 year. A few decades they may cease to exist. And there's a whole list of things. Arctic sea ice is disappearing, sea levels rising, global wildfires have become more intense and damaging. So, and the list goes on. The question is, what can we do about it? So this program is focused not so much on the complaints about what the climate is doing, but what are the solutions that are available to everyday people, just running their lives. And HeatSmart tries to remove the barriers to individual action, and we do that by trying to make sure you can get the lowest costs. We provide information. People tend not to appreciate what heat pumps can do for their homes at all, and so it's a big educational effort to get that out. And then to just give you confidence in the path forward. So we spend a lot of time vetting the installers that are our installer partners. We don't make any money from any of the sales in this program. The HeatSmart program doesn't, but the installers are in business. And we think it's a win-win event for residents and the environment alike. These are not supposed to be, oh, I feel bad about my carbon footprint and I'm going to sacrifice, the comfort of my home for a second-rate system. These are cutting-edge improvements in the comfort and health of your home environment. They have lower operating costs than other fuel types, and they have much lower carbon footprints, which we do care about. So this is a pie chart, and it covers the carbon emission contributions from different sectors. So, how much comes from our homes? 21%. How much from transportation? 37%. And of course, transportation is more than half us. It's the cars we drove to get here tonight. So that's a really big footprint. And commercial, a lot of that is sort of when you go to the mall, those buildings are all heated and air conditioned and stuff too. So a lot of the same, even though this program isn't trying to address those kinds of large buildings, the same issues apply. So we want to reduce all of these sectors and make the emissions smaller, but nobody likes to talk about having less pie and shrinking the pieces of pie. So instead, I'll talk about footprints. But all I mean by a footprint is what is the size of one of those sectors? How much area does it have? And everything has a footprint. So you're not going to go through this program and have no footprint. You're a real person in a real world, and everything has a footprint. And so what we really care about is how big are they? How permanent and disruptive are they? And where will they take us? So the HeatSmart program is very interested in carbon footprints. So this might be the size of the carbon footprint of your home now. And notice that it's rather gigantic. If it were coming down on the roof of this house, it would be bad news for the house. But it doesn't need to be that big. So we could improve the insulation and seal up cracks so that your energy is not just being wasted and escaping for no good reason. And we could shrink that footprint. And we could replace the furnace in the basement with heat pumps, and we would shrink the footprint. We could trade the car in the garage for an electric car, and shrink the footprint. We could get an air source heat pump hot water heater and shrink that footprint. And then we could run it all on wind and solar energy, and we'd really get down to a very small footprint. And that little baby footprint is really the end goal that I'm hoping people can reach. I'll talk about zero carbon and the zero carbon path. The zero carbon is sort of an abstract concept, because I told you already, everything has a footprint. You can't not have a footprint. So you can't truly ever get to zero carbon. But it's kind of like navigation with the North Star. It gets you where you want to go by paying attention to it, but that's where you're going to go isn't actually to the North Star. So the zero carbon pathway is a very useful concept for making judgment calls and figuring out what choices should I make. And we hope to, what we really hope is that you can say, honey, we shrank our footprint. So we're also, the program aims to save you money. In some cases, this would actually be cheaper than fuels you might be heating with. If that's not the case, we're still trying to offer the lowest prices that are available to make these changes. And as I said already, we consider this to be an upgrade rather than a break-even scenario in most cases. So the heat pumps can keep you warm in the winter. They often, for no extra cost, it's also an air conditioning system. You push a button on a remote like this, and it turns from a heater to an air conditioner, the same units. And they have great stable temperature control and better zonal control. So why did Solar Tompkins create HeatSmart? It's because 75% of our energy in our homes, that residential sector, is all used for heating. That includes space heating and also our hot water, which is quite substantial. More than 70% of that is currently from fossil fuels. Residents need help to understand what these options are. Some of this technology has improved tremendously over the past even few years. And it's hard to keep up with all of that, so that's the purpose of the program. The installers also need motivation, but also the opportunity to really focus with their customers on the best climate-friendly options. Because what happens most often is that the heater is broken. People don't do anything until the system doesn't work, and then it's the middle of winter and your heating system isn't working and you want it fixed tomorrow, and that probably means you're going to say, just bring me another furnace like the one that's down there now because I don't have time to go shopping. So we're hoping that some of you will be ready to go forward with some of these suggestions in the near future, but if not, we still hope that you go away with a better appreciation of these options for when the time comes. And I've got a 1-minute video here that I want to play for you.
The heating is very even, that our little one has been able to spend the whole winter crawling around on our hardwood and tile floors without getting chilly, even in his short sleeves here. And that we really like that we've been able to remove all the combustion products from our home.
And it's been easy to use. We haven't had any issues. And the units don't make much sound. So that was really important to me, that they're quiet.
And I think to add to that, as I have asthma, so it's a clean form of heat, and I really appreciate that.
What surprised me most was the cooling effect in the summer. We have been uncomfortable in the summer in the past, and last summer we had some really hot days, and we were sitting here at 70 degrees, very, very comfortable.
Well, it's just totally the right thing to do as a global citizen, to try to get our needs met and heat our house and cook our food in the most efficient way possible. So it's just the right thing to do.
So those were a few quick shorts. I'm going to run through a summary of a larger group of focus group people that went through the program last year. Heat pumps are a feel-good item. People, the home is more comfortable afterwards, and that's something that people can appreciate, and they appreciate each other for helping to make it happen. One friend told me that his 17-year-old daughter was the first time in a year or more that she thought he'd done something really smart. So HeatSmart allowed us to take steps that were otherwise daunting. So again, we're just trying to explain these technologies as simply but concretely as I can, good pricing, and the ease of choosing an installer with confidence. We have what we call the HeatSmart tours, and if people have gone a certain distance along this path and they've gotten an installer has come and assessed their home, given them a proposal, a recommendation, then all of a sudden people say, well, I've never lived with a heat pump. I want to see one in action before I make a decision like this. So that's when the tours become very, very valuable. And we'll be having those all the way through the summer till the end of July. Gives you a chance to see them in action, but also to talk to some of these people that were just in the video I showed. It's people like that are opening their homes. They can talk to you whether the equipment has lived up to their expectations. Was the installation process, a reasonable one, or was it, were there problems? So it's a good way to get grounded. And as the one woman said, cooling, air conditioning. People are getting these for heating systems, and they can't believe how much they like the air conditioning component that comes with it. Even people who didn't think they necessarily needed an air conditioner love them when those hot days come around. So we're going to talk a little bit about air sealing and insulation. And in an average home, heat is going to rise to the upper levels. Just naturally, hot air is more buoyant and rises up. And so that hot air is concentrated up near the ceilings and trying to get into the attic. If the attic and the roof have a lot of air chinks where they can escape, then you're losing a whole lot of heat out the top of the building that you want to hold in so that you don't have to replace it. It's money being lost. And as that leaves up there, it creates a suction that's pulling cold air into the lower stories. And you start getting an actual circulation of air that they refer to as the stack effect. It's a little bit like a stovepipe. When you first light the match, it doesn't draw very well, but as it gets hot and you get a stream of air moving through it, it actually reinforces itself. So that kind of dynamic can happen to some extent in a house when we're heating it, and we don't want that. In your fireplace, you do want it, but we don't want it here. And here's interesting data from the Department of Energy. In a typical home, if all the leaks were added up, it would be like having a window open all winter long. So that isn't concentrated in one spot. You don't feel it as a terribly cold spot necessarily, but it's costing you a lot of money in your heating bills. And I won't spend a lot of time on this. R value, as you probably know, is a measure of insulation capacity. The higher the number, the better. You want large R numbers. And different parts of the building will be recommended to have different R values. So these are aimed at putting the most resources where it makes the most difference, like the attic flat. I told you all that heat wants to go up, so getting a good insulation at that point does even more good than, say, insulating the basement. So in our area, a quarter of the houses in New York State are 75 years or older, and I think probably in upstate Tompkins County, probably even more than that. 42% of those homes have no foundation insulation, and a substantial number have no wall insulation. So here is cellulose. There's not a whole lot to see, even if the lights were dimmer. Cellulose is a natural material. It's granular or fibrous. It can be used loose in an attic like this. If this is an unfinished attic and you don't use the space as a living space, you can just pile the cellulose up on top of the floor. You can also pump it. So when walls are identified that lack the insulation they should have, rather than ripping the whole wall out, you can drill a little hole, pump cellulose in there, fill up the cavity, and then seal the hole so that you don't know anyone was there. So it's a natural material. It doesn't in itself provide an air or vapor barrier, and it has a moderate R value. Another insulation material that might be recommended to you is spray foam. All of our spray foams in this program are closed cell. These foams are shot out of a gun, a wand, as a spray, and then they harden in place. It does provide very good air sealing, especially the closed cell instruments, foam products that are offered in our program this year. And one important point is that these all have what we call blowing agents. The blowing agent is just a carrier gas. It's something that gets it out of the pressurized tank, carries it to the wall where you want it, and then the gas dissipates and leaves the plastic there. But they need something to help them do that. And it used to be that these blower agents were all hydrofluorocarbons, and they had very high greenhouse gas coefficients themselves. So even though your wall was better insulated afterwards, you'd had a pretty big carbon footprint just putting it in. The good news is that we now have fourth generation blowing agents that have been developed to meet that challenge, and these do not have that same greenhouse gas problem. So they're much greener, and all of the HeatSmart installers are using fourth generation blowing agents. So you won't get a recommendation for fiberglass insulation. This was one of the standards for a long time, but it doesn't have a very good R value. There are a number of ways in which it can be toxic or an irritant to different people. And it's also very porous, so air can move through this too easily. And if it's in a wall and you've got that stack effect going that I was talking about, this lets it get exaggerated because the air can move up through the fiberglass too easily. There are a few health and safety issues that we observe with the spray foam. There needs to be excellent, they don't outgas very much once the plastic dries, and that happens in a day. But when they're first put on there, there's a chemical hardening reaction going on, and that does give off some gases, and so you don't want to be home during that process if there's a lot of spray foam applied. And we recommend a 24-hour reoccupancy. So, go take a trip to Niagara Falls or go to a friend's house and play cards all night, whatever is fun, but just a day. And then there are some hazardous insulation materials that may already be in your home that can complicate some of this work. One of those is vermiculite. Vermiculite used to be used much as the cellulose that I was showing you now is currently used. And vermiculite itself is not a bad thing. It's in potting soils. Anytime you get a potted plant, it's going to have vermiculite in it usually. Vermiculite is a mineral. They mine it out of the ground. The problem is that there was one mine in Montana that was very active in the 60s and 70s, 80s, and in that mine, the vermiculite seam that they were mining was contaminated by an asbestos seam. So all of the vermiculite that came out of that one particular mine was contaminated with asbestos. And unfortunately, that mine produced about 70% of all the insulation materials for the country during that period that it was operating, so they realized there was this problem. So that requires special approaches in order to get rid of it if you actually had vermiculite in your house. And pure asbestos insulation is often on old stovepipes, insulation on ductwork, and they'll replace that too to get rid of the toxicity. The value of an insulated and air-sealed home is to save money on your utility bills, first of all, because they estimate maybe 30 or 40% for many homes of the energy is just being lost rapidly through poor insulation. It varies from home to home, of course, how well the home is already insulated. It improves the interior environment of your home and eliminates a lot of common problems. So you have better humidity control, lower chance of ice dams up on the roof causing damage and dangerous situations. There's reduced noise from outside, and your home has there's more integrity to the envelope, and you find less pest intrusion. You know, the insects and other pests don't have the easy access that they would have if you've got big chinks here and there. Okay, so that's enough about insulation for now. I want to talk about heating systems. And when an installer comes and gives an assessment of your home, they will also collect information that allow them to calculate just what is the heating demand that this house is going to have. And the estimate that they'll come up with is done two different ways. One is with a mathematical program that takes the sizes of the rooms and the R values of the walls and ceilings, and it runs a program. And they also do what they call a blower door test, which is they mount a big fan in the door and they try to pull air out of your house. And they see how easy it is to do. If it's really easy to do, that means that your house is really leaky. It's easy for the air to be flowing in to replace what goes out. But they'll also look at your past heating bills. So they should be able to make sense out of what they've calculated and what you seem to use in the home. And if there's a big discrepancy there, they'll figure out why. It might be the way you're using it, the house, and so it might be real. Or anyway, or maybe there are some big air leaks that they haven't caught yet that they need to. Heating system sizes are given in the units of tons, and a ton is equal to 12,000 BTUs per hour. And that's kind of an obscure unit. That's the amount of heat that it takes to melt a ton of ice. And we're not on an ice economy anymore for heating and cooling, but we still use those units. We still talk about tons of heating capacity. So what is a heat pump? It runs on electricity, and it uses refrigeration technology. So that's a really key fundamental point. The classic electric heater is a resistance heater, and you plug it into the wall, and the coils glow red and radiate the heat into the room. These don't do that. These take that same electricity and they use it to run a compressor, and they circulate a refrigerant fluid through a closed loop, and that refrigerant can pick up energy either outside from the air or from the ground. It can move it into the house and turn it into heat energy. So they can heat in the winter, they can pump it in the opposite direction if you want them to. Anytime, like I said, just a button on the remote turns it into an air conditioner. They can pump against the temperature gradient. So in the wintertime, even when it's very cold outside, you can still pump heat into the house. It can because you're just concentrating it. You're not, and they're super energy efficient. So if we say that electric space heater that was glowing red, it took all of the electric energy and just converted it into heat. So you could calculate from the voltage and the current flow just how much energy there was in that electricity, and that's how much heat you're getting out of your space heater. And they're often considered to be 100% efficient because they're right there in the middle of the room. There's nowhere else for the heat to go except where you want it. But these guys, if you took the same amount of electricity and you used it to run that compressor, you get 2.5 to 3.5 times as much heat into your house for the same electric use. Because we're not converting the electricity into heat in such a crude fashion. We're using it to run that compressor and run a refrigeration cycle. So there's two basic types, air source and ground source. just named after where they get the energy from. There's also air source heat pumps for hot water heating. So these are pretty exciting units. They can be a large chunk of that heating bill. And at the same time, this is a relatively simple standalone unit that goes down usually in the basement. And so it's relatively inexpensive to install compared to a heating system that needs to be delivered through your home. They're best used in a semi-conditioned basement, meaning that the basement is allowed to be cool. It's not kept at full living space temperatures. They're about 3 times as efficient, 300% efficiency, for the same reason that I was talking about. They're using much more sophisticated technology to get heat where you want it. And for many homes, this represents a low-cost opportunity. You can take a big step on that carbon path, and it can pay for itself over a short period of time. So, because their operating costs will be so much lower. So then we've also got air source heat pumps for space heating. And what's diagrammed here is a ductless mini split. So here's the compressor I've been talking about. It's the size of a suitcase outside. Could be bigger, depending on what kind of a unit it is. And these are what we call inside heads. And these lines that are connecting them are indicating the circulation of the refrigerant. And so that's just going through little tiny copper tubing. It's not big tubing. There's no venting. You're not pushing air around from one place to another. So that's the ductless part. They're ductless, and it's a mini split. So your refrigerator at home, your pumping is a cycle, it's using the same principles of physics. It's pulling heat out of the inner chamber of the refrigerator, but the back of your refrigerator gets hot, right? They always say, don't put it up against the wall all the way, or don't crowd the edges, because it has to get some air circulation or it'll overheat. So they're doing the same thing that these are doing. So this would be the cold side, and they all have 2 sides, a cold side and a hot side for a refrigeration unit. And because these are separated, unlike your refrigerator where they're physically connected, these are separated, so we call them mini splits. We've split the refrigeration cycle into 2 places. So, covered those. An important point about these is that in just the last 3 years ago, we were saying there was some great new technology that was good for colder climates. But in the last, about 3 years ago, they released what I would call the true cold climate models that have technology that can operate down below minus 13. What?
You have some.
Yeah, we do have some heat pumps, although I don't know whether these are the kind have the super modern technology in them. I'm doubtful because they aren't that new. But yes, those are inside heads. Those are these guys that you see on the wall. Probably a little bigger than the ones that would go into a home, but that's the idea. And so these guys can go down to minus 18, minus 19 Fahrenheit. That has been the result of some of the best engineering groups in all of the big companies, Mitsubishi, Fujitsu. They've been focused on these because they're the best selling units, and they also see them as the future. But it means that they're not just good at pumping heat when it's cold. They are more efficient, energy efficient as air conditioners. They are more energy efficient at mild temperatures. They're just better technology. The best improvements have been incorporated into these lines that weren't present in some of the older units. Then there's ground-sourced heat pumps. Oh, one thing I want to say one more thing here. There's a couple of different kinds of air-source heat pumps that can do this, and some of them are called multi-zone, And that's what's actually diagrammed here, because one compressor outside is attached to more than one inside head. There's also what we call single zone air source heat pumps, where every inside head would have its own dedicated compressor. And then those are usually smaller compressors than the multi-zone ones. But you'd need multiple units. And they both have advantages and disadvantages. The single zone ones tend to be a little bit more cost effective for, for if you need a certain tonnage of heating capacity, it's a little bit lower price tag. But there are some good advantages to the multi-zone. You don't have to have a whole bunch of different compressors scattered around. So then, the ground source heat pumps. So here we've got a refrigerator-sized unit that's down in the basement. And the entire refrigeration cycle is in there. Oops. Yeah. So here, you've got water that is circulating through loops in the ground that is pumped in to the bottom. It experiences a very cold environment with the cold side of the refrigeration cycle. It leaves colder than it was when it came in from the ground. So it might have been coming in at 50 degrees. It's leaving at 40 degrees. So heat has been taken out of that water from the ground, even though the ground was colder than you want your house to be. That heat is then compressed and concentrated in the hot side of the refrigeration cycle. And in this example, it's connected to a forced air system. So that hot side is warming up air that can then circulate through the whole house. And lots of times if you've got a current existing forced air system with any kind of a furnace, sometimes you can just replace the furnace with one of these units and keep the heat distribution system that you're already using.
What about a radiant heat system in the floor?
Yes, so this particular one that I'm showing here is connected to an air handler, but you can get heat pumps that are designed to replace a boiler, and that they would heat water that could then go to radiant floors or other hydronic systems. So both of those kinds of systems can be dealt with a heat pump. And for the forced air, you can also, we've also got air source heat pumps that are an option. So you can look, there's a number of options to look at if you have that situation. The ground source heat pumps need to have these extensive loop fields where water's circulating through. It's not getting in, it's not getting away. The same water recirculates again and again, but it's coming out of that heat pump colder than the ground. It comes back to the ground, it gets warmed back up to 45, 50 degrees, eventually circulates back into the basement. This is quite large. The scale's a little bit deceiving to the eye. This is probably 6 or 7 feet deep, these trenches. And as the label says, this is 250 feet long. So this is called a horizontal loop field, and people out in the country may have a good space for this. If you've got the room and you've got deep soils so that you can do that with just a trencher of some kind, then this can be the most economic way to get a loop field in the ground. And they last, although it's quite a disturbance here, they last 50 to 100 years. So you'll never have to do this again. You know, this system will last. But a lot of people don't have that kind of space in room, and you can also do vertical wells. So with just a 20 by 20 foot footprint, they can come in with drilling apparatus, just like you were drilling a water well. Go down 100, 200, 300 feet, and put a comparable kind of loop field vertically in the ground. So just a few quick pros and cons for the air-sourced versus the ground-sourced. They're both great systems. So it's really a matter of choice. The air source heat pumps, some of their strengths are the ductless versions especially are complete units. So you buy one of these, you're getting the inside head, you're getting the outside head. The cost of connecting them for a short distance is already in the price that are listed on our website. If it's a very long run, there are some extra charges for that. But relatively speaking, they're very simple, and you just need to buy the units, and that's the main cost. Oops. Multiple units inside are all individually controlled. So this is a big thing. If you have six of these kinds of heads in your home, the inside heads, you've got 6 zones. And you can turn the heat up in one room and down in another. They're all independent of each other. They have a very small footprint for the equipment, no digging, always provide air conditioning as well as heating. So these air source heat pumps never fail to give air conditioning. We'll get back to that. The things that maybe they aren't as strong as, say, the ground source heat pumps, you might not want to have so many inside heads. That's a fair bit of plumbing. Outside compressors are exposed to the elements. So these units probably last 15 years. These latest and greatest ones may last longer, I'm hoping, but they haven't been around long enough to prove it. So, but the industry expects them to last, judging by older models, for 15 years. The maximum BTU output does decline at very low temperatures. They're still working, but they aren't capable of as much heat output. That's just a design issue. And any of the installers will calculate what your heating load is, how much heating capacity you need at low temperatures, and they'll figure out the appropriate amount of heating capacity to install. And their energy efficiency isn't as high as the ground source heat pumps. So the advantages of a ground source heat pump, they have the highest energy efficiency you can get. They take care of all kinds of heat distribution systems, both forced air and hydronic. The hydronic systems don't automatically get air conditioning. And it's not the fault of the heat pump, it's the heat distribution system. You don't want your radiators all through the house to be cold and sweating and dripping. And so there's a limitation there. There are some ways that they can put special units in. They can add what they call a fan coil that can run off the boiler when it's cold water. And those can act sort of like the inside head of one of those mini splits. They can deal with the condensate. But when they do forced air, you do get air conditioning pretty much automatically. There is a NYSERDA incentive that has been proposed, and we have a very high confidence that it's going to get accepted. It's for $1,500 a ton for ground source heat pumps only, not for air source heat pumps. The air source heat pumps are cheaper, though, to begin with, so they can still be very economical. This still needs final approval, but twice the legislature sent a bill for a tax credit for geothermal heat pumps to the governor's office, and the governor vetoed it, both of them. But this incentive plan is coming out of the governor's office. So we really think that it's going to be, it has already gone through a public comment period. They are analyzing those comments, and they should, within the next few weeks, tell us the final official news about this. It will be retroactive for the whole year, and the only bad thing that I ever hear about it is that they haven't funded it with enough money. So it would be a reason to do the work this year while the fund is still able to, because it's sort of like the solar incentives were. They only were good until the money ran out. And as I said, the ground loop systems last for a very long time. Downsides are just that they are more expensive. If there are issues with the heat delivery system, those can run up extra prices. The air source heat pumps usually have their own heat delivery system, so you're not worried about those kinds of interactions. And they take a lot more land area. So, yeah. You are here at one of our public meetings. Thank you very much for being here and coming tonight. The point of this meeting is to get oriented. After my presentation's over, you can mingle through and talk to each of the 3 installers. I strongly encourage you to talk to all the tables. And then, if you're interested enough, we hope that you will enroll. Enroll is just filling out a form on our website, the Solar Tompkins website, and it doesn't cost anything, and there's no obligation to buy anything. What you're doing when you enroll is you're saying, I'm interested enough that I'd like to have one of the installers come to my house, give me a free assessment that won't cost anything, and tell me what their recommendations are for how I could make this home more comfortable. I've already talked about the tour, so I won't belabor this, but right about here in the process where you are getting recommendations from the installers is usually when people start really wanting to see the equipment in action somewhere and talk to people who are already living with it. If you get excited enough, you'll have gotten a proposal, and then you would sign a contract. And that, not until you get here, have you made any kind of financial commitment. There's no commitment to buy anything just because you've investigated and gotten an assessment. And then finally, installations. I just want to point out that there is a cutoff here for enrollment. So enrollment only goes to the end of April. It's a limited term program. There's all the way to the end of July to get these assessments and recommendations, to think about them, do whatever research you might want to do. But there is still a deadline here. If you want to get the pricing that we've negotiated with the installers, you would need to meet those deadlines. And all the installations are supposed to happen by the end of this calendar year. So enrollment, as I said, is done online. When you enroll, we ask you to pick one installer. You say who it is that you want to have come out, give you your free assessment. And then, because we're going to ask you to choose that installer when you enroll, it's really important to circulate and talk to all the installers at a meeting like this, get a feeling for who you want to work with. We vouch for all 3 companies. They're all excellent. So you need to decide who you feel best working with. Oh, and I should say the pricing is already negotiated and public. You can go onto our website. There's a pricing sheet that you can download. It's got different products and a column for each of the different installers, and you can run down through that pricing list. And if you want to shop that way to make sure you're getting the lower prices, you can do that. It's a very long list, so it actually is more useful to people when they've gotten an initial assessment often, and they know what lines actually matter to them. Oh, but so you do have to start that way, and what we find is that a majority of people who go through the HeatSmart program, they like that. That's a feature, because they really don't want to talk to 4 different installers and have to be there and go through the same. They just want to have the confidence that the one they've chosen is a good choice. And that's great. That's part of what our program is trying to provide. But if you don't fall into that category, and there's a fair number of people who say, no way, I'm not spending $20,000, $25,000 on this fancy heating system without talking to at least 2 installers, see if I get the same story. So if you feel that way, after your first assessment, you can have a second evaluation. You just have to tell me, and I'll set that up for you.
Is there a cost for that second one?
No. So the envelope assessment begins with a discussion of your goals, will inform you of insulation needs and options, provides the data to properly size a heating system recommendation, and it will result in one or more proposals for recommended improvements. And they'll do a number of things. This is that blower door that I made reference to. They also do infrared scanning. They'll do a full energy evaluation of how well your insulation is working. There are some financial incentives out, especially for low-income families. There are some excellent incentives through NYSERDA. You can get as much as $7,000 towards the insulation side of what I've been talking about. Doesn't apply to heat pumps. And for families that have a little bit higher income, there are 50% matching grants. And there are unsecured loans that are available at very reasonable interest rates. The heat pumps, the air-source heat pumps do not have any cash incentives, but they can qualify for those low interest rates. The ground-sourced heat pump, I told you about that $1,500 per ton that we strongly believe we're going to hear is in place by a few more weeks. And you know, we lost a federal tax incentive in December. It expired. Supposedly this was a clerical error. It was supposed to be part of the renewed tax credits for wind and solar and heat pumps, only somehow heat pumps got left off the list and nobody noticed. You can believe that our government would be that clumsy. NYSERDA actually has loans regardless of your income, but as your income level goes up, the loans have higher interest rates. And they are still, you know, maybe attractive. It's still an unsecured loan. It's not having to count against your mortgage or other assets. But some people find that getting a home equity line of credit is the cheapest interest rates that they can get. So I want to run through sort of the dollars side of how these compare to other forms of heating. So I'm assuming in this analysis that follows that there's 3 tons of heating capacity. That's a modest-sized house, typical building. What happened? And here's what I calculate it would cost to heat that house for an entire year using all these different fuel types. And you can see what I'm assuming for the prices of the different fuels here. So it ranges from around, you know, $900 for gas to $2,700 for propane, which is the most expensive. An air-sourced heat pump, however, could heat that same house for only $760. So that's even less than gas, if we're just looking at operating costs. We're not talking about the cost of installation right now. And if you got a ground-sourced heat pump, it'd be down to $500 because they have the highest energy efficiencies. In terms of carbon footprints, same house, 3-ton house. These are the metric tons of carbon dioxide that these 3 fuels put out every year, and we don't care that much what the exact numbers are, but it's pretty sobering to think that 5 to 7 tons of carbon dioxide is given off by each one of our houses just for heating alone in 1 year, every year. So how much of that can we get rid of if we switch over to a heat pump system and it's super high efficiency? So for air-sourced heat pumps, we can get rid of 60% or more of the carbon footprint. And for ground-sourced heat pumps, we can get rid of up to 75% in some cases. So those are really large reductions in the carbon footprint. And I'm still assuming that you're on NYSEG's grid, that you're just buying your electricity from them. So if you can't do everything at once, you can't put solar on the roof and get the heat pumps and do the insulation because that's just too much capital for 1 year. This is a huge step even if you just stay on the grid. And that happens, those numbers are so low for 2 reasons. The first is just that super efficiency. You're getting 3 times as much heat for the same amount of electricity use as classic heating modes. But another one is just that our grid in this region of New York, central New York, has a fairly low carbon footprint. We've got all the hydro coming from the Canadian border, and also, whether you love them or hate them, there's the nuclear plants along the North Shore. So we actually have a very low carbon footprint. I personally hope that eventually they'll phase out those nukes and replace them with wind and solar. But in the meantime, even before they do that, here in Tompkins County is a great place to be making this conversion, both economically and also from a carbon perspective. And of course, if you do buy PV, you can get rid of what's left here. You can get it down to 0. Okay, so now that was operating costs. You've installed the system, and that's what it costs to run it. But you have to buy these systems if you want to enjoy them. So in this example, we're still looking at the same 3-ton home, and I'm dealing with an air-sourced heat pump system that costs about $12,500. And this is 3 single-head, single-zone air-source heat pump units, which are the cheapest. The multi-zones are slightly more expensive per unit of heat. Not tremendously, but it's still noticeable. So here's what based on those same numbers you already saw. This is, instead of annual, this is monthly, what these 2 fuels would cost. Here's the lower operating cost of the air source heat pump. If you add in the loan payments for a 10-year loan at 4.5%, you come up with a total cost for the heat pump system of $196, at least during that 10 years that you're paying it off. So if we compare that then, for the heating oil, that's a little bit more, and you actually are paying about $46 more a month. Now, it's worth noting that for that, you've gotten a free air conditioning system thrown in. It's not just a heating system. You've got perhaps more zonal control than you used to have. So there are a lot of comfort issues that come with that. And the systems last longer than 10 years, so eventually you are getting the full value of this differential just to the operating costs, and you eventually, come out okay even with the heating oil. With propane, it comes out in your favor the first month, even paying off the loan, paying off the operating the electric costs, and you save quite a bit of money over the 15 years. Now, in this example, I have assumed that you have a brand new gas heater or whatever your heater is. It's in great shape, so you would value it, that there's no reason to get rid of it. But a lot of people feel like they're soon going to need to replace their heating system anyway. If that's true, then I shouldn't count the cost of replacing the furnace when I do those cost calculations. I should just look at the difference between what it would cost to put in, because the real question we want to know is it worth the extra cost to put in the more expensive air source heat pump system? Would you make money for that? You're going to put in a heating system. You're not going to let your house go cold. And it does make quite a difference. So here are 2 examples where it's the same home still. Oil furnaces cost more in general than a propane furnace, a new propane furnace. But if I subtract these numbers from the 12,000 and then do my calculations, you see that heating oil too, it becomes a great move right from the start. And propane, you're saving a lot of money by making these changes. So if you feel that your heater is near the end of its lifespan, this is actually more the truth of what you're looking at. And this is the same analysis. I won't spend a lot of time because I need to finish up, but this is for a ground source heat pump. It's more expensive, but we expect to have this incentive. So the cost of this system was $16,800. And it's the same pattern, although because the heat pump system is more expensive, the cost per month, the loan payments, whatever, to pay it off are a little bit higher, and it shows up here. One thing you'll notice is that I've added another column here, savings to 25 years. I didn't want to claim that the air source heat pumps would last that long, but these will. So it makes sense if you're looking to look long term. And similarly, if we look at this from the perspective of, well, I have to buy a new furnace of some kind or other because my old one's worn out, then the ground source system, even with the higher costs, is saving you money right at the start and tremendous amounts of money over its lifespan. Here's the next HeatSmart tour. It is this Sunday. It's an air source heat pump system at the home of Charles and Kathleen Woodcock. And they live here at Crescent Place, but you can see here's Highway 79 coming in from Caroline and branching into Seneca and Green. So quickly, there is a demonstration project. So I'm stepping outside of HeatSmart a little bit here. This is not part of our official program, but we are helping to find suitable sites for a study that is being done. So NYSERDA has funded a demonstration project which is being led by Tatum. It's not a formal part of the HeatSmart program. And the point is to expand the options available to homeowners with water-based distribution systems. And the expansion is to be able to do it with air source heat pumps as well as ground source. Ground source have been doing that for a long time. You can talk to any of the installers that do ground source heat pumps, and they could deal with your hydronic system within the program. But air source heat pumps have been used that way in other parts of the world, but not here yet. And so they're trying to get a demonstration that it works in our climate and under our conditions. And there's no guarantee that if you said you were interested that you would necessarily be chosen. They're trying to find 5 sites that fit all their criteria very precisely so that they can draw some conclusions even with that small sample size. But there's no cost if you are interested. And some reasons you would be, you've got a boiler that needs replacement. There will be some incentives from NYSERDA for this particular air source heat pump system, whereas there aren't any incentives for other air source heat pumps. And you get extra intense monitoring by Tatum's best engineers because their whole point of the demonstration project is to know exactly how well it works and did it work as well as we thought and how does it compare to the previous energy use of the house. So you'll learn a lot about your home, and your system will be working as well as it possibly can. The other considerations, though, is by definition slightly experimental. They're trying to prove that it works, so you're buying into that. And I want to reiterate, you can do it with a ground source heat pump system, replace your boiler, and that's something that's tried and proven. I'm really close to the end. Get Your Green Back is a great program. They do energy advising. If you want to have somebody who's not a company at all, but it's just volunteers that have been trained to come look at your house with you, contact the energy navigators with your question. You can do that. They'll answer questions online, by email, or even come out if that's what's appropriate. And there's a sign-up sheet for that in the back at the Solar Tompkins table. Seal the Cracks is a voluntary carbon offset program. They use the money they raise to help low-income homes right here in Tompkins County make improvements in their home. And they are looking at trying to fund a few heat pump systems and more insulation for some of those low-income families. And then if you are interested in solar, the Solar Tompkins, although that's where we started, we are not currently offering PV systems or installers that are doing them, but there is a program that's going on right now that does. So Cooperative Extension, Cornell Cooperative Extension, has what they call the Go Solar program. And I love our friends at Cooperative Extension, and I just wish, like anything, they had stopped there. But they had to add this Tompkins. So it's Go Solar Tompkins, and nobody can tell the difference between that and our website. So if you want to get to the HeatSmart program, it's just solartompkins.org. If you want to know about PV systems, it's gosolartompkins.org. And they're having community meetings a lot like this. They do have both rooftop and community solar options in their program. Community solar is where you've got too much shade or your roof isn't appropriate for mounting solar panels, but you buy a share of a solar farm somewhere, and you get your energy from there. So I want to acknowledge all the HeatSmart board members, all volunteer, past board members. You know, our program, as I said, was designed and put together. Funds were raised all by volunteers.